Today we're going to be talking about the limit definition of a derivative, and this is an introduction before we get into some rules about how to find derivatives. This is just the idea of it put out on a nice whiteboard here. So I have a function x squared, that's f of x here, and we're going to show why this formula here can help us find f prime of x. Now f prime of x means the derivative, right? What a derivative is, remember we talked about limit approaching a value. A derivative now is looking at what is the slope of a tangent line. What's a tangent line? Well, a tangent line is a ray that intersects a curve at one point, but it does not intersect the curve anymore other than that. So, for example, if I wanted to find the tangent line at x equals 0 for the function x squared, we know that the tangent line would look something like this, right? Hopefully you can see that. Completely flat, the slope is 0, right? I don't want to draw it on the line here because that would jump over it, but notice how I offset it a little bit. That slope is 0, but I want to prove that that's 0. That slope is 0, right? That's the whole idea of a derivative, is finding the slope of a tangent line, which is, say, that one. So a tangent line could also be like this here, right? Runs congruent with the parabola. And I'm actually going to go ahead and make this parabola more defined, kind of like this here, so we can better show the idea of what we call the difference quotient, right? This formula here for finding f prime of x given a function f of x says when the limit as h approaches 0 for f of x plus h minus f of x over h. So pretty simple. This helps us find the slope of the tangent line at any given point. But how does it work? What is h? Good question. H is any point on the graph. So for example, h could be here, right? Point h. There is some distance here, which is h, right? Now that we defined h, so some point relative to the other point, the point of interest, let's look here. The limit as h approaches 0. So this is as this point here gets super close, right? Not at 0, but approaching 0. So we could bring it halfway, that would be closer, or we could bring it right butt up against. So let me just show you the idea of bringing h really close to 0 and how it defines the tangent line. Remember that a secant line, that slope is just y2 minus y1 over x2 minus x1, right? So let's see how the slope of the tangent line changes as h comes closer to the point of interest. Let's go with the point very far away. So let's make a secant line. All right, so we would say that slope is not quite the slope of the tangent line. It's pretty far away, and that slope is greatly positive. All right, now let's look at this one here. How would we compare it to the last one we saw? Well, notice how it went like that. Now it's kind of like that, right? It's getting a little, the approximation of the tangent line is getting a lot better. Okay, now let's go to this point here. Look at that, it's getting even closer. And as we bring that point super close to 0, it will basically reflect the tangent line that is actually at 0, which is a slope of 0. So let us now work out the algebra of f prime of x, what we call the limit definition of a derivative here, to find and prove the slope or the slope of the tangent line of x squared at 0, 0 is actually 0. So let's see this here. So we need to define f of x plus h. Now when you do this, you just take f of x, and anytime you see an x, you add x plus h. So for example, if f of x, in this case, and I just want to make sure you guys can see this. Okay, yes you can. F of x is x squared, so f of x plus h would be x plus h squared, right? Pretty simple. And then it's just all over h. So let's put this together. So we're going to say f prime of x is equal to the limit as h approaches 0. F of x plus h, so x plus h squared. And then we're subtracting x squared all over h. Now we can do some simplification. Let me bring this over a little bit so you guys can see it a little better. Okay, so here's the work. So we're saying f prime of x is equal to the limit as h approaches 0. Let's FOIL out the x squared. Now, when you get higher ones, like to the 4th, to the 5th, there's something called Pascal's triangle, which we'll look at a little later. But this is x plus h times x plus h, so we're going to do the FOIL method. Hopefully you guys know how to do that by now. X squared plus 2xh plus h squared minus x squared over h. Quite simple. So all we do is we're going to see that x squared minus x squared is just going to cancel out. Alrighty, so we have f prime of x equals the limit as h approaches 0. 2xh plus h squared all over h. This should look pretty good. And then we're going to say that f prime of x. Now here's the important simplifying step that some people might miss the first time they do this. Notice that it's the limit as h approaches 0. So let's actually evaluate at 0 to figure out what f prime of x is, right? Because we're saying the slope of the tangent line, or the derivative of this function, is equal to that limit as h approaches 0. So what happens is we plug in, first we're going to actually cancel. Before we do any of that, we're going to notice that there's an h over an h, so we can actually simplify this like so, and then that's to the first, so this is 2x plus h. Now we evaluate at 0. Sorry about that. F prime of x is equal to, so we don't have to have the limit notation anymore. Plug in 0 for h, that leaves us with 2x, right? And when you get a function, when you take the derivative for a function, you're not given the slope at a specific point. You're given a formula to find the slope at any given point, right? So, for example, we're saying that f prime of x is equal to 2x. This tells you the slope at any given point on the graph. So if I wanted to evaluate at x is equal to 0, well, we know the slope would be 0. So f prime of 0 tells us that the slope of the tangent line at 0 is equal to 0. So, and that's what a derivative is. dy dx literally just means small change in y for every small change in x, right? So if we evaluate the f prime of 1, right, that would be 2. The slope of the tangent line is 2. So we go over 1. If we go 1 x value out, the slope of the tangent line is now 2, right? Rise over run, it's 2. We evaluate it at f prime of 2. We get 4, right? The slope of the tangent line is increasing exponentially. We would expect that for a function like this, right? As we go up the graph, it's exponentially growing, right? And this is the slope that we're getting. This gives you slope. So, quite simple there. So when we, hopefully this makes sense, right? We kind of proved here that at 0, 0 for the function x squared, the slope of a tangent line running at that x coordinate on that curve is really 0. In the next video, we are going to actually look at some rules. We're going to look at what's called the power rule, the quotient rule, and the product rule, and the chain rule. We'll actually do the chain rule separately, but that's going to make this process really fast. It's rules for a reason, and we don't have to do f of x plus h minus f of x over h. It can get complicated and stupid, and it's not fun. But yeah, take care, everyone.